So a professional employee in a large corporation receives an average of 41.7 emails per day. So I think what I'm going to do as I go through this, let me just, receives an average of 41.7 emails per day. Most of these emails are from other employees in the company. Because a large number of emails, employees find themselves distracted and are unable to concentrate when they return to their tasks. I don't understand why they don't turn the email off. In an effort to reduce distraction caused by interruptions, one company established a priority list that all employees were to use before sending an email. 1 month after the new priority list was put into place, a random sample of 45 employees showed that they were receiving an average of 36.2 emails per day. The computer server through which the emails were routed showed that the population standard deviation is 18.5. Here you go. Has the new policy had any effect? Use a 5% level of significance to test the claim that there has been a change in the average number of emails received per day per employee. So step number 1 is to do what? Survey says, state the null and the alternative hypothesis. So let's do it. Null and the alternative. So what do we have? An average of what? 41.7. And we want to know what? Has there been a change? So if there's been a change, we're not given any sort of direction. So we can come back and say that mu equals 41.7. And the alternative then is mu does not equal to 41.7. Step number 2. Survey says, what do we do? Compute the test statistic. Are we going to use a Z or a T? A Z. Why are we using a Z? Because the sample size is 45. And what else? We have the population standard deviation. Very good. So we know that Z sub TS is equal to X bar. X bar is what? 36.2 minus mu under the null hypothesis, which is what? 41.7 times the square root of 45 divided by 18.5. So this is equal to negative 1.99. I promise you from this point forward you can take my words. I've been using these lecture slides for quite a while now. So why don't you just take my word, and then if you want to make sure you can do the computation, I'll let you do that over the weekend. Step number 3, survey says, draw a picture. Very good. So we're going to draw a standard normal distribution. So is this going to be a two-tailed test, one-tailed upper, one-tailed lower? Two-tailed test. So I need to come down here, over here, and shade both the upper and the lower. So my alpha level is what? 5% or 0.05. So how much area is going to be in each tail? 0.025. Very good. So again, you have two ways of doing this. You have this lower region area right here. So you can look up 0.025 in your charts, or you can use the inverse norm command. And what will you put in for the inverse norm command? Very good. And you should come up with 1.96 negative or 1.96 on the upper part. So our test statistic is negative 1.99. So step 4, we need to put this in. So here's where our test statistic is. So continuing with step number 4, what's our decision? Reject. Reject the null.